Hello, this is Mrs. Grizafi. We're on 9.06 for pre-calc today. We're talking about graphs of polar equations. So this will be our last lesson for Unit 9. I know it's kind of been a couple of units or a couple topics put together into this unit. Last class, we talked about graphing points on the polar axes and converting them from rectangular to polar and vice versa. Today, we're going to just dip our toe in the water, so to speak, with polar graphs, and we're going to talk about how to just kind of look at what potentially they will look like. And this is my hope. My hope is that I help prepare you that if you do take more math classes later on, that you've at least seen this and have had some experience with it, because there's a lot more depth that you can go into this topic. So just a very skimming the surface of the polar graphs. The vocab that we're going to start with is the same as we talked about last time. You have a pole, and the pole is your origin, same as your origin right here. And then the polar axis is your positive x-axis, which would be the same as your initial ray if you were graphing your an angle. Then that would be your initial ray for that angle. Before we start doing it on the polar axes, we're going to do it on your rectangular axes. So we have rectangular set of axes right here. We're going to graph r equals 4 sine theta. So we're going to graph it as if it's y equals 4 sine x, of what we're used to seeing. First thing we always do is we find our amplitude, which is the number out in front, and take the absolute value of that. It's already positive, so it'll stay 4. Our period is 2 pi over b. Our b value is what's in front of the variable x, which is just a 1. So that would be 2 pi over 1, which is just 2 pi. Next, we talk about our interval, which is what we're going to go up by on our x's. So your interval is you're going to take your period and divide it by 4. Our period is 2 pi over 4 is going to give me reduced to pi over 2. And then lastly, we're going to write out our 5 key points. We're always going to start at 0 unless you have a horizontal shift. So that would be if you had like something in the parentheses after sign, x plus or minus a number. And then since our interval was pi over 2, that's what we're going to go up by. So we're going to go 0 plus pi over 2 gives me pi over 2. Pi over 2 plus another pi over 2 gives me pi. Or you could think of it as 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which reduces to 2 pi. So you're going up by 1s in your numerator and your denominator staying 2. In the bottom, you may be able to figure that out without your calculator. If you need to use your calculator, put y1 is 4 sine of x, then you would make sure you are in radian mode since we're using our pi's here. And after you put your y1 in, go to your table. Let's make sure your table start is at 0, because that's where we're starting our table, right here at 0. And then your change in table is going to be your interval. So our interval is pi over 2. And we're going to be in radian mode. So then you can go to your calculator, type those in. So again, real quick here, I'll just show you y equals 4 sine x. And then we want to make sure we're in radian mode right now. Go to your table set 0 and pi over 2. We want to go up by, go to our table, and then we're just going to copy these values down. So I have, if I can get back to my document, here it is. We would go 0, and then 4, 0, negative 4, 0. On our x-axis, we were going up by pi over 2, so this is going to be pi over 2. Then this will be pi, 3 pi over 2, and then 2 pi. We're going up all the way to 4, so I'm going to just count by 1s. All right, I'm going to change colors to graph it. So I'm at the point 0, 0. This is sine. Remember, sine always starts at the midline. So we're at 0, then we're going to go up because it's positive 4. So you go up to 4, then back to your midline, then down to your minimum, then back to your midline. Connect it with a nice smooth curve. And there's our graph. So that's using our rectangular set of axes. We see 4 sine of x. This would be y equals 4 sine x. So an amplitude of 4 and a period of 2 pi. Now I want to graph it on my polar axes. So to graph it on my polar axes, I'm going to first change my mode in my calculator to polar mode. And then I'm going to, what will happen when you switch it to polar is it's going to be in terms of r and theta now instead of x and y. So we're going to do a table for theta and r. So we're going to want our table start to be at 0. I'm just trying to write all this out before I switch to the calculator. My change in table, we're just going to make it 30 degrees for this one so we can see everything. And for the ones we're doing, we're just going to always kind of keep this consistent. Again, we're just kind of looking at what these graphs are going to look like. So you're always going to start at 0 for the purposes of this class and then go up by 30. And since we're doing 30, that means I'm talking in degrees. So I also want to change the mode to degrees. So that will do at the same time we change it to polar. So let's go to the calculator and see what we've got going on now. So I'm going to go to mode. I'm going to change this to polar. So if you go down here where it says function, we're going to go over to polar and hit enter. Then I'm going to go up here and I want to change this to degree for now. And now if I go to my y equals, you'll see it looks a little bit different. Instead of saying y equals, it says r equals. So our polar equation is r equals 4 sine theta. So we're going to type in 4 sine theta, and actually shows up as a theta now, where normally it shows up as an x. So there's our 4 sine theta. And go to your table. Oh, I didn't switch my table start. So now I'm going to start at 0. And my change in table, I don't want pi over 2, I want 30. So now I can go back to my table. And this is what I'm going to copy down. And we're actually going to go all the way up to 360. So we're going to get quite a few points here. So I don't know how to have both of these open at the same time. So you guys use your calculator and I'll use mine. Okay, so I'm just going to write these out. So I've got 0 is 0. And here, if you want, sometimes it helps to separate them. So sometimes when I set up my table, I just start with putting in my degrees. And then we're just counting by 30s here. So 120, 150, 180, and then 210, 240, 270, and 300, I think we'll fit it, and 360. And now I'm going to fill in my other side here. So at 30, we're 260 is 3.4641, 90 at 4, 120 at 3.4641, 150, 2, 180, 0, 210, negative 2, 240, negative 3.464, 270, negative 4, 300, negative 3.464 again, 330, negative 2, and 360, 0. And now we're going to plot these. And if you want, you can also take a look at your graph here, which you'll see it should look like a circle. Ours is kind of stretched out a little bit, kind of looks like an ellipse, but it should be a circle. So let's see what it looks like. You can see here, we're going up. The reason it's stretched is because we're going up by a larger number on our x-axis than we are on the y. See how they're more spaced out? And then the y little tick marks are closer together. Okay, so now we talked last class about how to plot these. So we're going to do the same thing. So we're plotting 0, 0, so that's going to be here. But the next one is when it's a little different. So 30 degrees, and then we're going at R is 2. So we're going to find 30 degrees, which is right here. This is 30, 45, 60. So we find 30 degrees, and we're going to go 2 circles out. So 2 units out. And that's our next point. Then we're going to go to 60 degrees. And then we're going to go 3.464. So we're going to go a little less than 3.5. So 1, 2, 3.5. So a little bit less than that. At 90, we're going to be at 4. So 1, 2, 3, 4. And we go another 30 degrees, we'll be at 120. And at 120, again, we're a little bit less than 3.5. Then we're going to be at 150. And at 150, we're 2 circles right here. And then at 180, we're back at 0. Now let's keep going. At 210, we're going to be at -2. So at 210, which is this line over here, we're going to be at -2. So we're going to go to the opposite quadrant since it's -2, and we're going to count 2 up. Oh, well, we already have a spot there. So that one didn't really help us because we already had a point there. And we might see that happen the next few times. So then we've got 240. We're at -3.46. So here's 240 in quadrant 3. I want to flip it. And then I want to count 3, a little less than 3.5, and there's a point right there. So we've repeated that one as well. And then we go to 270. At 270, we're -4. So we go to the opposite side and we count 4 up since it's negative, and we already have a point there. So I think you're starting to see the pattern, hopefully. Then at 300, we're at -3.46. So we jump to the opposite quadrant and we already have a point there. And then at 330, we're at -2. Again, negative, so we jump to the opposite quadrant, and we already have a point there. And 360 is 0, which we already have a point there. So when we connect these, not very perfect, but best I could do for now, this would be a circle. So pretty cool how you can see the difference when you graph it in a polar set of polar axes versus on the rectangular axes. So it's just looking at it in a different way. Let's look at another one. We're going to do these the same way. And here are your steps in this box over here. So always make sure you're in, I want you in polar mode and degree mode. To polar and degree mode. So my calculator is already in those, so I'm good to go for now. We're going to create the table, fill in theta side of your table first. So let's do our theta and R. So I'm going to start with, for these, I'm always going to go up by 30. So it gives me a nice array of points from 0 to 360. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Go to your calculator, and then we're going to find our R values, and then we're going to graph it. So we go back to our calculator, go to our y equals, clear this one out. We're going to do 2 plus 2 sine theta. Go to our table set, make sure it's at 0 and 30. We know we're already in the correct modes. And now we're just going to copy down our R values into our table. So at 0, we're 2, 33, 63.7321. 90 is 4, 120, 3.7321, 153, 182, 210 is 1, 240 is 0.26795. So now we see we got a little different values this time for these lower value, higher angle measures. 300, 0.26795, 330 we're at 1, and 360 we're at 2. Well, it's time to graph. So I've got at 0 degrees, I'm going to go out 2 circles. At 30 degrees, so this is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Okay, so we go out 2 circles. Now at 60 degrees, we're going to go 3.7. So 1, 2, 3, and more than a half, closer to 4. At 90, we're going to go a full 4. And then at 120, again, we're going to go 1, 2, 3.7. So we're just approximating. 150, we're going 1, 2, 3 circles out, and 180, we're going to be 2. Now at 210, we're going to only go 1 circle. At 240, we're going to go 0.2. So we're quite close to the origin, but not quite there. At 270, now we're at the origin. 300, we are very close to the origin again, about almost 0.3. 330, we're 1 circle away. And 360, we're back at 2. So very similar to our circle, but a little bit different here at the bottom. See how it kind of comes up and goes around, and then it comes back in again. So we actually call this a cardioid, which is a heart-shaped curve. It's a lemicon, is what it's called. And the formula or form that you would see this in is if you have r equals a plus or minus b times sine of theta. So here a and b were both 2. So anytime a divided by b, if they're the same, so they equal 1, that tells us it's going to be that cardioid, which is a heart shape curve, which is kind of cool. So there's a couple different lemicons that we can look at depending on what A and B are. So this one creates that heart shape. And let's see, if we look at it here, you can see that nice little heart, how it comes in on your calculator. All right, next up, number 3. You're going to graph r equals 4 cosine 2 theta by hand. So I think you guys have got the process down now. So again, make sure your table start is at 0. Make sure you're in polar and degree mode. And you're going to make your change in table 30. And then create your table. So I would pause your video now, go ahead and fill in your table, plot your points, and see what this one looks like. Okay, and I'm going to do it here. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, and 300, 330, 360. Most of the time, I just spent writing out this long table. So here at 0, we're at 4, 2, -2, -4. And these, again, we are just taking straight from your calculator. And then we're just going to graph them. So again, you've got your 30. If it helps you to write in these angles, go ahead and do that. If you don't feel like you need to write in the angles, then that's not necessary. We know from this graph how it's set up, 330, 360, at least if you maybe just label the 30 degrees and the 60, that first quadrant, we'll know what we're counting by. All right, so now at 0, we're at 1, 2, 3, 4 circles out. At 30, we are 2. At 60, we're -2. So here's 60. It's in the first quadrant. Since it's -2, we want to jump down to the opposite quadrant, which would be quadrant 3, and go out 2 along that line. So it's that straight line that forms. You're just going the opposite direction. And 90, we're at -4. So again, 90 is this line right here. But since it's -4, we want to go in the opposite direction, not towards that 90 up there, but away from it. So 1, 2, 3, 4 on the 270 line. So plotting 270, comma, and 4 would be the same thing as, or for 270 would be the same as plotting -4 and 90. So now we are at 120. So 120 is -2. So here's 120. We go to the opposite quadrant and count 2 out. At 150, we're at +2. At 180, we're at 1, 2, 3, 4. At 210, we're at 2. And so I've got a lot of points going on here. At 240, we're at -2. So now that bumps to the opposite quadrant. And at 270, we're -4. So that one's going to go up to here, to 90. And 300, we're at -2. So we're going to go to the opposite quadrant there. And 330, we're at 2. Got a lot of points here. Sometimes it's helpful to plot as you go to. 360, we're at 4. So what this one's going to look like is you're going to take your center here is going to go through these points like this. And it's going to create 4 different petals. Right here. So you've created a little flower. And this one, because it creates that flower, is called a rose curve. So if you have a rose curve, then you have it of the form a cosine n theta, or a times sine n theta. So what happens is if n is odd, then you're going to have n petals. So each of these right here is a petal. If n is even, then you're going to have 2n petals. So if it was 4, then you'll have 8 petals. So that is your rose curve. And at this point, again, this is just information for you guys so you understand where this is coming from in the form that it takes. What I want you to be able to do is just to be able to put this in your calculator, generate your table, plot your points, and connect them. I'd also like you to know that it's called a rose curve. All right, and our last one, number 4. Again, you guys hopefully get the idea of what's going on here. So put it into your calculator, write out your table, and then play it, and I'll show you what the graph is going to look like. Okay, so we have a point at 0, -1, and 30. You should have had -0.7321. So instead of going, and you guys should have written out your table, obviously. I'm just trying to save some time here for you. So instead of going to positive 0.7321, we're going to go to negative. At 60, we're at 0. At 90, we're at 1. At 120, we're at 2. At 150, we're at 2.7, so almost to 3. At 180, we're at 1, 2, 3. At 210, we're at almost 3. 1, 2, 3, but a little bit less. At 240, we're at 2. At 270, we're at 1. And at 300, we're at 0. we already have a point there. At 330, we're at negative 0.7. So instead of going this way, we're going to go this way. This one is a little bit confusing because there's so many points. So I'm going to show you what this is going to look like. -1, we already have a point. So this one is actually, it starts off as your circle here. But what happens is we have what we call an inner loop. So this one is a lemicon with an inner loop. So just kind of a cool looking graph too. So that's if, let me give you these formulas first. So R equals A plus or minus B cosine theta, or R equals A plus or minus B sine theta. Those would both give you a lemicon with an inner loop. Well, they give you a lemicon. If it has a lemicon with an inner loop, that means A over B would have to be less than 1. So here's our A and our B. So 1 over 2 is less than 1. It's 1/2. Okay, and again, you would show your table out for that. And I know there's a lot of points there, but knowing these formulas are helpful so that you can kind of figure out which graph it is. So just kind of an intro there. Again, do them all in the same way. Start your table at 0, change in table 30, make sure you're in polar and degree mode, and then show your table and then plot your points. And I hope you're all doing well and staying healthy and happy and math dancing. And I miss you guys and hope to see you soon. And pie out.